Today then we're going to do 9.5. 9.5 is broken up into two different sections. We have pyramids, which is Roman numeral 1, then we have cones, which is Roman numeral 2 on the back side of your sheet, or on the second sheet. With this, so pyramids, if you look at these, they all have triangular sides, yes? So in the three pictures you have there, but the bases aren't always the same. This one here, the base is a triangle. Here you have a square pyramid. Here you have a hexagonal pyramid, or basically the base is a hexagon. Good? With each of those, what do you notice about the sides, though? The triangles that are on the sides are all congruent? That they're all going to be the same. So if you wanted to find the area of one of these things, you could figure out the area of one side and then multiply it by however many sides there are. Now, the base isn't always going to be the same. So if you have a triangular pyramid, sometimes that base will be the same as the sides, sometimes it's not. But the two things we want to write down for pyramids, one is that they only have one base, as opposed to the prisms we were doing in the last section had two bases, the two parallel congruent sides. And pyramids also have triangles for all the sides. We okay on those? So this is one of the new types of shapes we're doing in this section. Now I'm a little off the screen here with mine, but when we're talking about like the height, now we have two different types of heights for these pyramids. We have one which would be just like the normal height, how tall is it? If you're trying to fit this pyramid through the doorway, would it fit? And that height is always going to be basically starting in the middle of the base. So this right here is at the very middle of the base. It might not look like it in the picture, but that's in the middle of the base, goes straight up to the very top. So that first one for the height, I'm just going to say height is how tall. So how tall. And if you want to, you could say the middle of the base to the top. The slant height, that other one, is what's the height of the slant? What's the height of the side? And you'll notice in the little picture then that it starts in kind of like the middle of the side and goes right up the very side to that vertex, to that point at the top. Fair enough? Which one of those do you think you're going to use in finding the surface area of the sides?
Slant height. The
slant height, exactly. That height in the middle doesn't tell you like for the triangle. So if you would flip down, we have this example here. And I was going to kind of skip this example if I can get away with it. But if we were to take this square pyramid here and unfold those sides, you agree it would give us a net kind of like this here. And you could go through and you could label it. You could say, all right, this side right here is going to be how long? 8. So all of these should be 8, right? So if you wanted to, you could put in the 8s. And now the heights of the pyramid, so if you wanted to say, all right, what's the height of my pyramid right here? That's going to be the 5 for the height. So for slant height, you could say that's the height along a side. So the height along a side. And you could go and, I'm going to put a little star by it, use slant height. And they'll use the abbreviation for that. They'll use a lowercase letter s. So I'm just going to do that like that. So use the slant height, this lowercase letter s, for area calculations, or maybe for SA, for surface area calculations. Cool. Does that make sense? Okay, so then the back side, you have cones, so Roman numeral 2 with the cones. What makes something a cone, if you look at the two examples in the upper right, is the cones, the base is always a circle. So that's one of my bullet points, so cones, so base is a circle. And they only have one vertex, they only have one corner, one point at the top, so I guess that's my other thing. So one vertex. And if you wanted to, you could, do a little arrow to it. But the vertex is always going to be that point at the top. Fair enough? So now the question is, what does a net of a cone look like? And I kind of spoiled it because I had it right there for you. But if you could take that side part and say, all right, I'm going to take and unwrap that side and fold it flat, it's going to look like this thing here. And the amount of this little wedge here, of the Pac-Man mouth, if you want to call it that, has to do with how tall the cone is. If we wanted the surface area of a cone, we need to figure out then the area of the two parts. We need to first figure out the area of the circle, and then we need to figure out the area of this ugly-looking thing, and combine those two together. Good? So I'm going to do them in two parts this way. So this equation, I would write it in your notes. or at least write it on your bookmark with all your things, but you may want to write it right here too. So I'm going to do SA, and I'm actually going to write like a little subscript they call it of a cone. So SA cone, something like that. On your bookmark, you could do cone colon, and do SA equals. But nice part is we just have one equation then that's going to work for any type of cone. And if we're talking the area of this part here, so what's that area going to be? They write it this way. It's 1/2 times a capital C, and capital C is going to stand for nice. So if you wanted to, you could like put a little label if you want to and write circumference. So circumference. So 1/2 times a capital C times a lowercase s, and we said a lowercase s stood for slant height. That right there is my s. So that right there, 1/2 times capital C times s, that gives me the area of this part that I shaded in blue over here. Gives me the area of that. And we just need to add to that the area of the circle, and the area of a circle would be, anyone?
Pi times R2.
Nice. Pi times r squared. Pi r squared. So then you could put a box on if you want to draw attention to it or kind of whatever. But this here is going to be the equation that we use when we're trying to figure out the surface area of a cone. My plan is we'll do one example, and once we're done with that example, we're done with the notes. So I stole this one from the book, but you've maybe seen the buildings where they store salt for the winter for the road commission. They're roughly this type of shape. So we want to figure out the surface area. So please, 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 my friends, show your work. And I'm going to space things out so I have room to write in some numbers. I'm going to do SA equals 1/2, then a little gap, a C, a little gap, then my S plus pi times r squared. But I'm just spacing it out a little bit so I can more easily kind of line up numbers below those different things. And now once we have that, we just start filling in numbers. So I can say, all right, I have 1/2 C. Well, what's C going to be? What's the circumference of that baby? Or how do I find it?
Well, you would do pi times diameter.
Okay, so we have two options, 2 pi r, or we have circumference as pi times diameter. Pi times diameter is going to be easier because we know the diameter is 30. So do you agree I'd put a 30 in for my diameter? So circumference is pi times 30. Here's where a lot of people take their calculator, punch it in, and get a decimal answer. I would really encourage you instead, though, to just write under C, I'm going to squeeze in there a 30 pi. Because pi times 30 is the same as 30 times pi. As soon as you get a decimal answer, we're going to multiply that by a number soon. And when we multiply it by that number, it makes that rounding that many times bigger. So I would avoid rounding until you get to the very end of the problem. Now we need to find s, this lowercase s. Lowercase s is the slant height. Okay, so slant height, what's the slant height going to be? Ooh. It's not 20, right? Because 20 is just the normal height. So if we're trying to find what's the height there up the side, how would we do that? So we're looking for this height right there.
Maybe use like a little triangle thing?
Yeah, perfect, Kayla. Use the triangle thing. Do you agree? Right here we have a triangle that's a right triangle. So I'm assuming by the triangle thing she means a squared plus, anyone? Equals c squared. And the slant height is going to be which one of those letters, A, B, or C? C. Because it's the longest, it's the hypotenuse. So I have a c squared there after my equal sign. And A and B have to be the two legs. So A could be that, and B could be this, or you could switch A and B. It doesn't really matter. But if we write them that way, A is going to be
15.
Oh, if I put my A on the side, though, so if A is this,
20.
so A is going to be 20. Nobody fell for my diabolical plan a second ago. People got that B has to be 15. Do other people see it too?
Yeah.
Because the whole way across is 30, we only need half of it. We need the radius, not the diameter. And that's real common. I actually made that mistake last year. I was marking tons of people wrong in something. Then I realized I put in the diameter instead of the radius when I was finding the slant height. So be careful. It's easy to make that mistake. So I take a calculator, do 20 squared plus 15 squared, and you should get 625 equals s squared. But we don't want s squared, we just want s. How do I get rid of the squared? Square root, nice. You divide if it was s times 2, but get rid of the squared by square rooting. And square root of 625 is a number. 25. 25. So 25 equals s. So now that we know what s is, we could just put 25 in our original equation up there at the top.
Yeah.
Now we're done with the hardest part. So we'll say this is 25. And now we're just going to fill the rest in. So plus pi times r squared. R is 15. So we have this equation. Our answer is going to be this thing here once we punch that into a calculator. Some people go through and try to figure out all different little parts and then write them down and add them all together. I would just take your calculator and just type it in exactly how it's written. So I'm going to grab a calculator and, okay, close to exactly how it's written. I don't like doing one. You could do 1/2 with a fraction key, or you could just type 0.5 times 30. Then you could do times pi, or you could just hit your pi button. So 0.5 times 30 pi times 25 plus pi times 15 squared. And you punch all that in, you get 1,800 and
84.
point.
955592.
Yep. So the book gives us this, or the calculator gives us 1884.9555592. And I would just choose to round that somewhere. I'd probably go in the 1885 seems a little bit much. You could do 1885, probably get away with it. But it'd look a little nicer if you did 1884 point, maybe a 96 or something like that. And because our units were feet, technically it's 1,884.96 feet squared. Yep, because it's area, it'll be our units squared. Make sense? The feet squared? Yeah. All right.
It looks really confusing.